So we'll see. All right, here we go. All right, so using what you just learned on table I, I'm going to sprinkle in some math here. So I'm going to write a reaction on the board, and I want you to find it. What's that?
It went out.
It already shut off?
Well, it has like this.
It just got the notification.
Yeah.
I think it just says like.
Can't see it. No, no, no.
It's working. It's fine. Okay. I'm going to write a reaction. You do exactly what you just did on the homework. Find it, write the energy on the correct side. Here we go. 2 carbon solids, so write this down in your notes, plus 3 H2 gas.
Did we actually have to write solid and gas?
Morgan,
Yes.
don't be lazy.
Oh. What's going on, Morgan?
Okay, well on the homework, I wrote the gases and the solids, and then when you
I
were going over
thought
it, you were like,
so.
you don't need to write that, and I was like, well, I'm sorry.
I did that? I said that?
No, that was her.
Oh.
And then when I'm sorry. You were wrong.
You guys should always write those.
Really?
A lot of times you can probably get away with not doing it, but that's just not good practice. So you
That's
should
on
do
the
it.
table, so you would know.
All right, so you find that reaction. Now you look it up and you find the value of delta H. And again, delta H is the amount of heat released or absorbed. So, where's it go? On the right or the left? The right, the end. Okay, good. Why? Because it's negative. It's 84, right? Okay, good. Now we're going to talk about moles. So, a mole is a certain amount of anything, really. If I wanted a mole of markers, how many markers would I need?
One. A mole.
6.022 times
Isn't it
10 to the 23rd.
Yeah.
That's why October 23rd was Mole Day. So if I had 6 times 10 to the 23rd markers, that would fill up maybe the entire school. That's a lot of markers. That would be 1 mole of markers. If you look over on the periodic table over there, if I want a mole of lithium, I would need 7 grams of lithium. If I wanted a mole of calcium, I would need 40 grams of calcium. If I want a mole of hydrogen, I need 1 gram
The
of
red
hydrogen.
number?
So the red number, the mass, tells you the mass of 1 mole of an element. So if I had, so for example, don't write this, just stay with me. If I had 7 grams of lithium, what that means is I have 1 mole of lithium, which means 6.022 times 10 to the 23rd particles of lithium. So all of those numbers are equivalent. So what I'm just reiterating, I've talked about this a little bit, this here is really important in this class that you know what that means. What it means is you have a certain amount. What is that certain amount? This. You do not need to know this for the regions, but you just have to have a concept of what that number means. There's no scales in the back where you can measure a mole of something. The only thing you can measure is mass. So if you know the mass on the chart is equal to 1 mole, that helps. So we're going to do more with this stuff down the road, but what you need to know today is what this word means, sort of. Just have a rough understanding so you're not completely lost. It just means a certain amount, okay? And we will come back to moles down the road. So let's just take that mole word and apply it to this reaction. All balanced equations, what's balanced mean?
Equal.
No.
The same. Like, you know, like.
Sort of, I mean, it could mean equal and the same as long
The
as you're...
balance being is straight. You
Yes,
know,
it
like
is.
the thing that you know. Yeah.
Yes,
That's
yes.
it.
So the number of particles on your reactant side are equal or are the same as the number of particles on the product side. How many carbons do we have right here?
2.
2. How many over here?
2.
2. How many hydrogens here?
3.
3 to the
6.
6.
6 hydrogens because you have this. Let's say that's hydrogen. You have 3 H2, so that's 1, 2, 3, 4, 5, 6 H's. Everybody with me?
Mm-hmm.
Okay. How many H's over here?
6.
6. Is it balanced?
Yeah.
Yes, same number of atoms on both sides. What law does that show? Conservation of mass. All right, good. Now, Here's what you're going to write underneath this. In this reaction, there are, write this down, there are 2 moles. 2 moles of carbon on the reactant side. There are 2 moles of carbon on the reactant side. There are 3 moles of H2 gas. I'll put my little G here. H2 gas on the reactant side. There is 1 mole of C2H6 gas on the product side. So, I'm going to start real slow here so you don't get overwhelmed. Okay. Where am I getting all that information from?
That green one at the top.
Like, where am I getting the 2, the 3, and the 1 from?
Right there.
Excellent. Like, where on the board is that number coming from, this number, and this number? Just describe it the best way you can. Where's that 2 found? Like the location on the board. In front of the carbon, good. Where's that 3 found? In front of the H2, where's the 1 found? In front of the C2H6, there's a 1 there, we just don't show it. What are those numbers called? Anyone remember, Paul? Coefficients, right. So when you balance an equation, these big numbers in front, so I knew you knew it, and I think you knew it too. I know a lot of you can look at it and say, well, it's right there. But what does that mean, and how do you get to that every single time? So what I'm trying to show you, one example, when you have a balanced equation, the big numbers in front tell you how many moles you have of each one. The big numbers in front tell you the number of moles you have of each one. What is a mole? 6.022 times 10^23 particles. You don't need to know that. All you need to know right now is that if there's a 2 here, you have 2 moles of carbon. If you have a 3 here, you have 3 moles of hydrogen gas. If there's a 1 here, you have 1 mole of C2H6. What if there was a 4 there?
4.
I would have 4 moles. What if there was a 10 there?
10 moles.
10 moles. Everybody with me?
Yeah.
Okay, what's the mole ratio, Murph, between carbon and hydrogen gas? Mole ratio between carbon and hydrogen gas.
2 to 3.
2 to 3. Why?
Because there's 2 and 3.
Because there's a 2 and a 3. Very good. Kayla,
Oh no.
what's the mole ratio between hydrogen and C2H6?
Is it the same? It's not like 3 to 3.
Well, this is 2 to 3.
Yeah.
So what's the ratio between this one and this one?
Isn't it the same? I have no idea. I'm
You
gonna
do.
be honest.
You're going off. Stay focused.
Okay.
If this is 2 to 3,
Yeah.
this mole ratio between this to this
Yeah.
is 2 to 3.
Mhm.
This one is.
The same. It's 2 to 3. Right? Or is it 3 to 2? Is it backwards?
Hold it. I got it. That's why I get paid all these big bucks teachers make. Right.
My
So
brain hurts.
stay with me.
I'm here.
Okay. 2 to 3. Right. 2 to 3 or 2 to 3. Those are ratios.
Yeah.
Now. 3.
Oh, it's 3 to 1.
There you go. Good job. 3 to 1 or 3 to 1, and that's okay. I hope I didn't embarrass you. So good job.
Oh, I don't care.
So when you guys are looking at reactions now for the rest of the year, and we're talking moles, mole ratios, this is how you do it every single time the rest of the year. It's actually a pretty important skill you just learned. Some of you may think it's easy, some more confusing. That's fine. But once you balance an equation, the big numbers in front give you moles. All right, I'm going to leave that alone. We'll come back to that down the road. So now why am I talking about this when we're using today? Talking about energy. All right, so on reagents, what they're going to do is they're going to give you a question or a reaction like this. Then they're going to ask a question changing the moles. They're going to ask you, how does that change the energy? So I'm just going to do a question with you. Hopefully it makes sense. Then we'll do some more on our own, and this is going to be your homework. I really want to give you homework where you got the quiz.
Probably not a
Let's
good
just see
one.
what happens first. All right, so let's write this question down. Okay, so using the above equation, and I'm going to try and word this like the Regents the best way possible here. Using the above equation, calculate the value, I know my V's and U's look the same, but that's value. Using the above equation, calculate the value of delta H. Now this RXN means reaction. This might be a new like symbol or abbreviation that you haven't seen. So that 84 on table I, the top of that column is labeled delta H. This is another way you're going to see it, delta H sub RXN. It's called the heat of a reaction. So this is the heat coming from this reaction. So that's what that stands for, heat of reaction. You don't need to know anything else about it, so don't get stressed. That just means the energy, the 84. So using the above equation, calculate the value of delta H if, and I'll keep this first example very simple, 1 mole of carbon solid reacts. So go ahead and write that down. These types of questions are all about ratios and proportions. Almost all the math and chemistry, Regents chemistry, ratios and proportions. So cross multiplying, dividing, kind of like the gas law equation, which you need to know for tomorrow. There will be gas law calculations. So I'm going very slow, and hope you guys follow me and you get it. So then when we get other harder problems, you're good. All right. So what is not what is? Sorry. How many moles of carbon do we have up here? 2. Why?
Because there's a 2 in front.
Because there's a 2 in front. Good. All right. How many kilojoules of energy are being released in this reaction?
84.0.
How many kilojoules of energy? What is the value of delta H in this reaction? It's 84.0. How do you know that?
Because it says it.
Because it says 84. But what if it wasn't written there? Where would you look?
On the table I.
Table I. All right. I'm going to back up. I'm going to repeat myself. How many moles of carbon?
2.
2. What's the value of delta H?
84.
84. Positive or negative? Negative. Why?
Because.
It's at the end. Exothermic.
It's at the bottom.
Okay. This is a little easier because I'm giving this to you. We did it together. On a Regents, they won't give that to you. They're going to give you the reaction. You're going to have to go to table I and look it up. Okay. So here's how we solve this problem. Write down exactly what I write down. 2 moles.
Is this for the answer?
I'm showing you how to solve it.
Oh.
2 moles of carbon over negative 84.0 kilojoules. That's a proportion or a ratio. It's a ratio. So what I'm taking is 2 moles is to 84 kilojoules equals, so we're going to fill in the proportion here. If 2 moles of carbon produce 84 kilojoules, then 1 mole of carbon produces X. So no questions. Don't really think too much right now. Just follow the concept here. So if an equation is given to you, table I, the delta H is given to you, the question the Regents is going to ask is they're going to change one of those numbers, the 2, the 3, or the 1. They're going to change one. And you have to see how the heat changes in relation to that. So if the carbon went from 2 to 1, the heat is going to change proportionally. And that's why a proportion works. So if 2 moles of carbon from the equation, from table I, produce 84 kilojoules from table I, this is something that's just given to us. All you have to fill in is this side. You read the question, it's changing the 2 to a 1. So this 1 mole, instead of 2, there's 1. How is the heat, X, going to change? So if 2 produces 84, 1 produces X. Anyone know the answer?
No.
Negative 48, or 42.
Negative 42 kilojoules. Good job. Then we circle our final answer. That's the answer to the question. So what I'm trying to teach and show isn't the math. I hope once you get it set up, the math you should be able to do. If that's the problem, then we're in a good place. Because the setup and the concept is the hard part. So when you're given an equation, the balanced equation and the delta H is on table I. The question is going to change that. In this question, it said, what if you have half as many moles? Well, if you have half the moles, you're going to get half the heat. You can think of fire. You burn 1 log or 2. You burn, 10 pieces of wood versus 20 pieces of wood. Typically, the fire is going to get bigger and there's going to be more heat. The same concept applies to these reactions. If I cut the moles in half, then the heat isn't going to be as substantial. The heat will be cut in half as well. So that delta H is based on how many reactants or products are in a reaction. So if I cut the 2 in half, I cut the heat in half. You with me for the most part? Hopefully? Alright, let me give you another one. And if some of you were with me a long time ago, just be patient. Everyone learns at different paces. Alright. I'm going to write a reaction down and ask you a question. I'm not going to give you any help. And feel free to, maybe pair up if you want. And you know what? First I'll give you a minute or two, a couple minutes on your own, then I'll have you pair up and talk about it. So I'll write a reaction down, give you a question, see how you do. Here we go. Alright, so 4Al solid plus 3O2 gas yields 2Al2O3. So there's the reaction, and I'll give you a question now. Calculate the value of delta H RxN if, and I'll make this one a little bit more challenging, 4.5 moles of O2 gas react. So, what you would do on a Regents, if this was a short answer, is you have to show work, label units, and then I always say circle or box your final answer. So, this is what you're going to do now. I'll give you a couple minutes or a few minutes on your own, then I want you to pair up. So, you're going to do exactly what we just did together, except on your own. So, talking about heat is the last part of this really big unit that starts off the year. It's like most of the first quarter. This is the first type of math we're going to do with heat. Monday, Tuesday, we're going to learn another equation for heat. But this is what we're doing now. So go ahead, take a few minutes. Use the example I gave you.
That's rough.
Looking better, Luke.
That's what I said
Feel
yesterday.
better? Feel better? Good.
Well, no, yesterday when I handed it to people, I said your face looks better.
Yeah, well, I try to say it a little nicer. Sometimes I'm just crass.
No, that was.
Kind of like rude.
Oh, yeah. You're not gonna lie.
The biggest mistake kids make with this, besides the math, so math errors is usually a thing that happens, which we can fix. So I'm okay with that, because that's just a mistake. It's not like you don't know how to. But the other biggest mistake kids make is they have the wrong sign in front of delta H. So it's supposed to be negative, they put positive, or it's supposed to be positive, they put negative. So make sure you have the right sign in front of delta H. That's usually like half the point. So let's say it's worth 2 points. One for the correct number and one for the correct sign.
Or five.
So when it says O2, it means O2, not O. Does that help? I'm trying to be a little vague. This is kind of how I help people. I don't really truly help that much.
Oh,
So,
yeah, I got it.
okay. All right. What, Morgan?
She's not wrong.
I said we've noticed.
Yeah, well, that's how it goes.
I told you my chemical intuition story.
Oh, you did it?
And I have
My
no idea.
inorganic chem teacher, junior year in college. I went to him and I was pretty stressed out. I had a lot going on at that point. I said, I can't figure out how to do his Latin. I can't type it up. I don't know how to do anything. He just looked at me straight faced and said, "That's your chemical intuition."
That would annoy me.
And that was it.
I think
He gave me
I
no help.
Through the roof.
I think I cried.
Yeah, no, I
Were
literally
you?
did. Yeah, no, honestly.
Well, I don't remember how I did. Not too, I didn't do too well on that,
Figured it out.
but I figured it out. I got through it, right?
I don't think I'm doing this right.
So anyways, the moral of the story is, there's a little lesson there I think I learned from him. Is as a teacher, you can't give too much help, right? You gotta let
Yeah,
kids
but
kind of
he
figure it
didn't
out.
give you
No,
absolutely
he
Does this
didn't
seem
have
like
help.
anything.
Like over
I give more help than he
Just
did.
say, you should grow us like something.
A little bit. Bring it to the water for me.
to write the problem here.
The watering hole. The old gator
Yeah, but
hole.
like you were like dying of dehydration.
Yeah, and he was holding water and he'd take it away from me. That's what he did. Say, you want this? Nope. All right, I see some good things.
And then you see.
I need final answers though, circled.
Hold on.
Oh, I didn't get that.
You get this?
Let me just say one more thing here quick. So what is the delta H on table I? On table I. It's 3351, right?
Oh, there's a 1?
Negative 3,351, correct? All right, how many moles of O2 do we have in the reaction behind me? 3. So if the question says you have more than 3, there should be more energy given off. So your number should be bigger than 3351. If that, well, but it is, so, but the negative is just to represent what?
That it's X.
That it's losing it. So the amount of heat does go up. It's just a symbol. It's just, the negative is just a symbol. It's not an actual negative number. All right, go ahead. Talk to each other. Pair up. See how you're doing. Don't forget about Katie.
I got negative 5. I did. So I did.
Don't think you get the 4 because there's a 4 right there.
But that's for.
I really have no idea what the heck I'm doing. You just said right up front.
And then
Wait,
the 4 minus 5 would be like.
Don't forget Katie. Get Katie involved.
Yeah, it's so okay, Katie.
And then the 4 minus 5 is.
Why do you read the one?
You.
What was that?
It's
Good.
I feel like the M needs to be better on those and like
I think so. I think if
I don't know. It just it really bothers me.
I hope like when you wear those to like a school and they're just staring at your shirt, it's like.
I think it looks like roots coming from the hands. I think that's cool.
Is that what it's? There's hands. Wait, what hands?
There's hands holding a basketball.
I like that.
I like the hands too. It looks like roots coming off the hands.
Not till there were hands.
All right, here we go. Now, before I go over this, I'm looking at your quiz tomorrow, and I'm just going to throw some little nuggets out there to help you here.
Nuggets? What are you talking
I'm looking at the very first question. You have to convert temperatures between Celsius and Kelvin. So make sure you know how to do that. Okay. Also on the first page there is a graph on the gas laws. Remember those 3 graphs? One of them's on there. Also, you definitely, there's a handful of questions on pressure, temperature, volume relationships. So just make sure you're good with that. Avogadro's law is on there.
We never watched
What
the
is
video.
that?
Yeah.
We gotta watch it.
Oh,
See,
right.
They don't even know what it is.
Sure. Yeah, we talked about it. So that was with my 2 liters of Pepsi and 2 liters of Coke.
That was
That's so
weeks ago.
stupid.
Right, that's what this is on. Gases, liquids. So if you have the same amount of gas, you have the same amount of gas. Just remember that. All right.
Being really intelligent. Figure out.
Ideal gases. You need the conditions where real gases will be most like ideal or least like ideal. So remember those? How do you make real gas most like
Low
ideal?
pressure, high temperature.
Low pressure, high temp to expand. Good, good. Let's see. The kinetic theory's on there. Gases move straight lines, all that jazz. Weak forces. There are 2 or 3 short answer questions where you have to use the combined gas law. You have to use table H. That's the vapor pressure boiling graph. And what else? There's some questions talking about or asking about temperature and forces of attraction and vapor. So it's nothing new. Anything we've talked about, obviously, I'm not going to give like brand new stuff on the quiz, but I'm just kind of briefly here throwing things out there. So those are the things you need to know for the quiz. And you know what? Let me see here. Where's that?
The bells.
Yeah, that's right. I wanted to make sure I did that instead of going over this. So I'll write out the answers to that review sheet. I thought I had it here, but I don't know what I did. I'll write the answers out, take a picture, send it. If you want to come get it at the end of the day, feel free to do that. You don't have homework. Just get ready, study for that quiz tomorrow. You will have homework due Friday though, or due Monday on Friday. That's it. I'll stop there. Bell's gonna ring soon.